Hi, welcome to Physics, the next segment, which is Physics of the Universe, Stars, and the Origins of our Universe. I'm Mrs. Maselli, and I will start off with a little bit about myself. I have three children. They're all out of the house. One is married. She got married about 4 years ago. The other two are in college and currently missionaries for the church. My husband and I have been married for 29 years. I went to school at Irvine High School, just a little south of Anaheim High School, and I went to college at Brigham Young University. And while I was there, I had an opportunity to study abroad in Bolivia on the Altiplano, and I got to participate on a small scale farm project, which kind of started my love for science. I helped the people of the Altiplano dig a well so they could have safe, clean drinking water. And that kind of sparked my interest to pursue my major in the sciences and to teach. I love to go camping and hiking. I cook a lot of Italian food for my Italian husband. We both play role-playing games like Dungeons and Dragons, and online we play video games like World of Warcraft. I am a musician. I play the piano and the clarinet. I was in band. I played basketball and did some track in high school. And my boys each played soccer and water polo. So kind of do a little bit of everything. Okay, so let's get into physics. So the last segment likes to tie all of the stuff we've talked about the whole year together with space and the universe and stars. So first off, what are stars made out of? And how do we know what's in a star? And how can we test that? They're so far away. We can't just fly out there. We don't have enough fuel to get out there. So what we can do is remember our chemistry and remember that certain elements have certain colors that they give off. And once we do that, we can look at each star through a spectroscope, and each star has a unique little fingerprint. And it shows us, oh, there's some hydrogen in that star, maybe a little helium, a little sodium. And each star has a little spectrum fingerprint that we can look at and see what exactly what elements are in those stars. And what's really neat is that helps us know how large the star is, how old the star is, and where it is on its life cycle. The other thing we can do is observe our star, the sun. The sun is a star pretty close to us, 93 million miles away. So we can study properties about our sun and make correlations to other stars that are out there that are also suns, and it can give us a pretty good idea of what's going on in the universe. Another thing that's fun to talk about is how do we go from all of this energy, look at all that energy being given off by the sun, and how do we turn it into this kind of energy? So how do we turn this into electricity to run the computers and turn on our lights and charge our phones and all the things we need electricity for? So that's a fun topic that we get to talk about in physics. Not only does the sun give us energy for electricity, it gives us a lot of other types of energy as well. We can do nuclear fusion. If we can do fusion on the Earth, like what happens on the sun, we would have free electricity for millions of years. We just need to figure that out first. We also can do fission and create explosions. And right now, not only is this energy given off with this nuclear bomb, but that's also the same idea of energy within our nuclear power plants, but it's contained. If you think about it, the other energy that comes from the sun is also important. I mean, just the light coming from the sun is a type of energy we need for life on our planet. If there was no sunlight, then plants wouldn't be able to do photosynthesis. And if plants didn't do photosynthesis, they wouldn't make carbohydrates, which is food for us. And also, plants give off oxygen for us to breathe. So if there's no light, there's no plants, there's no us. So that's an important source of energy from our sun. Another one is UV light. So sometimes we think of UV light as UV radiation as a bad thing that can cause skin cancer. but small amounts of it actually kill germs. It can kill the COVID virus if we have UV lights. It can purify water and get rid of the parasites and bacteria in the water. It can also provide us with vitamin D, which is a healthy thing and our bodies can't make by themselves. So the sun can give us all kinds of stuff. So we can have long wavelengths of energy to help us with our communication. It gives us heat to keep our water liquid, so we have liquid water on our planet, and light for life. Ultraviolet for skin and health and disease killing. X-rays to look into our bones, and gamma rays to use for medicines to kill cancers in our cells. That's what radiation therapy is. So all of this radiation originates from the sun. So what happens to a star? Well, they're born and they live out their lives doing fusion and giving off energy. And then some things happen to the stars depending on their size. And we learn about what happens to a star, what's its fate, what is going to become of it. We've learned about things like black holes and pulsars and supernovas and red giants. And one of the coolest things to know, our sun is right here, and we have millions of years before anything happens to it, so don't worry. But one of the neatest things, looking at all these things that happens to stars, is stars actually recycle their matter. So once a star lives out its life, which is a very long life, billions of years, all that matter doesn't just go away. It actually compiles and it becomes a new star, a new planet over time. So maybe we could learn something from nature's cycles and we could take care of things better here on our planet. So physics covers a lot of stuff. Things are going on, right? We've got to study about famous scientists. We learn about collisions. We learn about different forces. We learn about the motions of our planet, different energies given off, sound, vibrational waves. It's crazy. There's a lot of stuff to learn for physics, but hopefully it's a fun ride and we come out a little bit smarter at the end. Thank you for your time, and always remember, physics rules. Have a good night.